this one here, I can visualize a single degree as one small sliver of that circle. But the question is, how much of that circle am I measuring with 1 degree? Well, as you may know, there are 360 degrees in a circle. So this would be 1/360th of the circle. That means I should be able to draw 360 tiny little slivers making up this circle. That's fairly intuitive. Now, over here, we can also consider radians. Radians, just like degrees, are simply chunks of the circle, but they're much harder to visualize. In a single circle, there are going to be a total of 2 pi radians, which is about 6.28. If we double pi, which we would think of as 3.14. Now, this is kind of strange. So 1 radian is 1/6.28 of the circle. So maybe it's going to look like this, 1/6 about of the circle, right? And so there should be about 6 of them. Well, why would we even use this ugly number? Why involve pi? It turns out it's useful for calculations later on, for circumference and area and so on. But for now, accept that this is simply a more useful and practical number, while this is an arbitrary and nice looking number. Now that we know that degrees and radians both measure the same thing, they're just chunks of the circle, we can actually identify that they are equal to each other. So if I know that there are 360 degrees in the circle, 360 small chunks, that would be the same as saying 2 pi small chunks of radians in a circle. They're the same. Therefore, just like if we have 3/3 equaling 1, 5/5 equaling 1, I can write, because these measure the exact same thing, that 360 degrees over 2 pi is equal to 1. And that's going to be very useful for converting in a moment. I can then simplify and say, oh, well, 180 degrees over pi is equal to 1, because I divide by 2 on top and bottom. Now, this is going to be our core measurement. 180 degrees over pi is equal to 1. And at the same time, in fact, this is also equal to pi over 180 degrees. They're all the same thing, And we're going to see why that's useful. Now, on to some problem solving. Let's say we have 30 degrees and we want to convert it to radians. Well, I'm now going to reference my conversion ratios. I'm going to say, well, I want to make it become radians. I want to get pi involved. So I'm going to have pi on top. So I'm going to use the pi over 180 ratio. So I'm going to times it by pi over 180. That's going to give me, if I cancel out here, I'm left with a 3 and an 18, canceling out tens. Oh, 3/18. That's the same as 1/6. They both have a 3. I'm left with pi over 6 in this case. And so I can clearly state that 30 degrees is the same as pi over 6 radians. I've converted between them. Let's try another. Let's say we have 45 degrees. How would I convert? Well, once again, I have degrees. I want to turn it into radians. So I'm going to put the pi on top. I'm going to use this ratio here. And when I do that, I'm going to multiply by pi over 180 degrees. I'm going to cancel as much as I can. I'm going to say, oh, there's a 5 in here. Make it into a 9. There's a 5 in here. We can actually, for 5s, it's pretty easy. All you do is double the number. So if I have 180, I'm going to double that 18, turn to a 36 degrees. You can also just use a calculator. And then I say, oh, 9 and 36. What can I do? Well, they both have a 3, I think. So I'm going to cross off the 9, put a 3. I'm going to cross off the 36 and put a 12. And oh my gosh, we can keep going. This is a 3, turns it into 1. This has a 3, turns it into 4. So I'm left with pi over 4. So in the end, I can say that 45 degrees is the same as pi over 4. That would be my answer. Let's try now when we start with radians. Let's say we're given pi over 3 is an angle measure in radians, and we want to convert it to degrees. What I'm going to do is reference my ratios and say, oh, well, I need to get rid of that pi, right? So I'm going to use the 180 over pi, dividing pi out. Now to do that, I times it by the ratio 180 over pi. I notice, and this will happen very often, that these pi's are going to cancel. So I'll cross off the pi, and I'm left with 180 over 3. And when I divide by 3, I can say, oh, well, 3 fits into 18 6 times. I'm going to be left with 60 degrees. And that's my answer. So in the end, pi over 3 is equal to 60 degrees. And that's how you convert with radians. Let's try another. Let's say I'm given 225 degrees, and I want to convert that to radians. I'm going to once again look over here. I'm going to use the ratio that brings radians into the fold. That means a pi is on top, and I'll divide away degrees. It's going to be pi over 180. So I'm going to take my 225, multiply it by pi over 180 degrees. And then I'm going to cancel as much as I can. I think that there's a 5 in both of these, so I'm going to cross off this and try and divide it by 5. That will end up giving us 45 degrees over here. And then on the bottom, if we divide by 5, we're going to end up with 36 degrees. Furthermore, it looks like we can also cross these off and divide by a 3. So if I divide 45 by 3, I get a 15 degrees. If I divide 36 by 3, I get a 12 degrees. And one more time, I think we can get rid of this 15 and this 12 by dividing both by a 3. And I'm going to get a 5 degrees up here and a 4 degrees down here. Overall, ignoring everything I've crossed off, I'm left with 5 pi over 4. Now the degrees cancel. We don't have to write them anymore. And this is our answer. So in the end, 225 degrees is the same as 5 pi over 4. Let's try a tough one. Let's say we're given 7 pi over 4, and our goal is to convert this to degrees. I'm going to choose the right ratio. I'm going to try and get rid of the pi, so I'll do 180 over pi. And I'm going to multiply by that ratio just like always. So times 180 over pi. I hope you're seeing the repetition in this. It's always the same. Immediately, I get to cancel my pi's. And then I'm going to look for other things to cancel. What else can I cancel? Well, this 180 on top is even. That 4 is even. So I'll cross this off. I'm left with 90 degrees and 2 down here. Next, I can see that these are once again even. So I can cross off the 2. I'm left with a 1. And then if I divide 90 by 2, I'm left with a 45 degrees. This leaves me with 7 times 45 degrees. And when I multiply these together, I get 315 degrees as my answer. So 7 pi over 4 radians is the same as 315 degrees. And that's how you convert between degrees and radians. So every time, all you're going to do is identify whether you're converting to degrees or radians, choose the right ratio, multiply it, and then simplify, and you're done.